let's pretend I have a color function. The way the color function works is you tell me the name of the person, and then I'll tell you what color shirt they have on. So if I put in Mike into this color function, what will I get out? If you said red, then you are correct. In fact, if I put in anyone's name, it just tells me what color shirt they have on. That's the way the color function works. But what if I had an inverse color function? What would that look like? Well, with all inverse functions, it's just the backwards of the original functions. So instead of putting in the name and getting out the color of their shirt, I'm going to tell you the color of the shirt, and then I'll give you out the name. So it's like doing it backwards. So if I put in green, then I'll tell you the person that has a green shirt, and that's Tavon. So that's the way functions and inverse functions work. Inverse functions just relate it the opposite way. It's just going backwards. So let's keep that in mind when we think about sine. Now, sine of theta is some number. That's a function. So if you tell me the angle, I'll tell you the sine of that angle. So that's a table here of some of the sines on your unit circle. But let's think about the inverse function. The inverse is just the opposite. If you tell me a number that's the sine of some angle, I'll tell you what angle has that for a sine. So negative pi over 6 has a sine of 1/2. So if I put in 1/2 into the inverse function, I'm going to get out pi over 6. Does that make sense? I hope so. But I know what you're thinking. Some of you are thinking, but wait a minute, Mr. Salazar. You're telling me what's the sine, or sorry, you're telling me what angle has a sine of 1/2, and you're telling me that the only answer is pi over 6? Well, I just looked at my unit circle hat, or my unit circle t-shirt, or my unit circle necklace, and it turns out that there's a lot of angles that have a sine of 1/2. Pi over 6 is one of them, but so is 5 pi over 6. So, and if I keep going around, there'll be another angle over here that also has a sine of 1/2. Well, I'll tell you one thing. You are absolutely correct. But remember, we want the inverse sine or the arc sine to be a function. So in order for it to be a function, we have to restrict the domain. So what we do basically is say, look, I'm only going to pay attention to everything that's between negative pi over 2 and pi over 2. Everything else we can just cross out. It's like we forget about these guys and we forget all about these guys, and we only focus into what's in here. So the only answers you can get for inverse sine or arc sine is answers from negative pi over 2 to pi over 2. So let's look at this question. Arc sine of negative 1/2. So it's basically asking me what angle has a sine of negative 1/2. And if you look on your unit circle, you'd tell me, oh, that angle is 11 pi over 12. But is that the correct answer? No, because it has to be between negative pi over 2 and pi over 2. So the correct answer would be just the angle in the negative direction, right? The angle in the negative direction. So that would be negative pi over 6. So the only answers we can get are positive angles to pi over 2 and negative angles to negative pi over 2. Cosine is the same way, except the only answers we can get are from 0 to pi. So we basically cut off these guys and cut off everything here. So the only answers we get are between 0 and pi. Tangent is the same as, the range of answers are the same as sine. We basically cut off everything here and just pay attention to what's going on in between the asymptotes. And those are all my range of answers. It's going to be between negative pi over 2 to pi over 2. So hopefully that clarifies some things, and the analogy about these guys wearing shirts can help you think about the inverse trig functions a little bit clearer. It's basically just doing the opposite. We're just doing the opposite. Alright, good luck guys. Okay, bye.